I would like to start our class with the instruction and the rubric for our project 1. Okay. So I'm going to share the okay. I'm going to share the first one will be the, let me begin with the instruction. Okay. So as you know, I hope by now everyone has watched the video, and that video is purposely made to assist you on the project. And if you have any problem, maybe you can, refer and rewatch again the video so that everything will be clear. So for this class, I think I'll just touch a little bit on the instruction and the rubric. Okay, if maybe if you have any questions or any or whatever ambiguity, we can discuss. Okay, before we proceed with the first chapter. Okay, so the total mark is 20%. Okay, so I think for the instruction is clear. Now the only thing would be for the what we call I think the one that I would like to touch would be okay. And for okay, first the video. Okay, for the video, I don't specify any video platform. Okay, you can use PowerPoint. Okay, you can use Sway. So whatever video platform that you can use to make your video for 3 minutes video, you can use that as long as your video will contain the whole materials that we want you to submit that will be in PowerPoint slide. So the rubric that I gave you is for your what we call for your guidance. Okay, for your guidance, so that you would know what kind of a project that we can call as insufficient project or good project or maybe excellent project, and that would be reflect your content of your report. Okay, so for the video presentation you can use anything as long as it will be in a video form when you submit it to me. Okay, and remember the video only 10%, so don't put too much time on making the video. But of course, I would expect that you come up with what we call clear video presentation as well as the images that you use to support your explanation of your project. Okay, for the PowerPoint slide, okay, for this part, I think it will be very easy since we have given you the guideline, the what we have specified for you. I think it's very clear. You just follow the instruction for the PowerPoint slide for you to submit in terms of PDF later on. Okay, so it will be on 6 to 8 slides only, not more than that. So in order for you to avoid any zero mark, okay, because we have assigned one data set for one team only, so there will be no possibility of the same project between team to team. Okay, but of course among lecturers we also discuss and we will sit down and see what our students will come up with the video and the project, and that will be to make sure that there will be no duplication or repetition, and that will be to avoid this particular zero mark given to you. Okay, so far for the instruction, do you have any questions? Ask now, okay, because more or less you have only 4 weeks from now to submit your report and your video presentation. Any question regarding your what we call your instruction for project 1? So means that for chapter 1, there will be no test, no quiz. So the assessment solely on the project. Okay. Do you have any more questions? Otherwise, I will just go to the rubric. Any questions so far? Anyone? Hello?
No.
No.
Understood.
Okay, understood. Okay, and then let us go to the rubric. Okay. So this rubric we share with students so that student would know how the lecturer will do the marking. Okay. So simply when we receive your report as well as your video, we will give mark based on this particular what we call criterion. Okay. I'm waiting for the what we call the bar. Okay. I need to touch the pen. The bar is not okay. Now, for insufficient project, okay. So insufficient if the item, okay, what you present us, the project background is not defined, the objective are not defined, so you will get 1 mark. Means out of 5, you will get 1 mark. Compared to excellent, okay, everything is clear, everything is explained, well defined, 4 objective given, so it will be 5 marks. For data description, the weightage 1 means that the maximum will be 5 marks only. So insufficient project would be wrong description about the population, sample size, and types of variable. And source of data is not stated. So means that I have given you the sources of your data. It's either the Department of Statistics Malaysia, Department of Statistics Singapore, or Department of Statistics Brunei. Okay, if let's say from the data set you don't know which one, okay, ask me. So means that the source you must be very clear. Which is the correct source? Is it Department of Statistics Malaysia or Singapore or Brunei? I will let you know in detail. And for the what we call the description, okay, sometimes your data set will be in terms of the details of the information given in your data set would be different from one data set to another data set. So it would be some of you may be very lucky because you can have a more what we call description of your variable samples or whatever information given. But somehow some data set maybe the information described will be less than the other one. Okay, so for that particular part, I don't want to make up what we call make up any just suka-suka buat description, but somehow logically you can create the scenario of your data set. And if you have any what we call problem to do that, means that for the first one, if you have any problem, you can discuss with me. I will help you out. Okay. So for fair project, you got wrong description and insufficient description. Wrong and insufficient description for the population, sample size, the variables, and so on. Okay. And the data source is stated. Okay. So you can see for good project, there will be clear criteria, very good project, and excellent project. So you can see one by one. But what most important, I think, is item number C. Because item C carry 20 marks. The weightage is 4. So it means that if your project is insufficient, so you get 1. So 1 multiplied by 4, you get 4 marks. If your method and analysis are excellent, so it means that you got 5. So 5 multiplied by 4, you get full mark, 20 marks. Okay, so please make sure all the criteria you look into one by one. Okay, when you do your project, look at the rubric and compare to your project content. Do you have what we call criteria for insufficient, or do you have criteria for good project or very good project? So you look at it one by one. So at least if let's say some of you do it last minute, okay, so you cannot think of more information to put in your report, so there will be no way I can help you. Okay, so everything must go within the criteria that we have stated from item to item. The same goes to conclusion. The weightage is 2. So means that if you have insufficient project, you will get 2 marks only. Okay, and I think I won't give the what we call detailed explanation, because I think the rubric is very understandable and you can clearly distinguish between insufficient, fair, good, very, and excellent. Okay, for the assessment rubric, anyone, do you have any questions or any what we call maybe suggestion before I close the rubric? Anyone? Is it okay? So if it is okay, I'll just proceed.
Okay.
Okay, thank you. Once I hear okay, then I will just proceed. Okay. Now, let us move to the this particular master list. I think yesterday I saw quite many respond in the master list sheet actually. But then this morning I realized some of the information I'm not sure whether missing, or I don't want to say that someone erased that particular information. But please, once you have maybe for example Darshini and Anita, okay, you have written which data set that you have chosen and you have put your team member, please snapshot that particular document and keep it. Okay, if necessary, whenever I check, if let's say your name is not there, so means that I need to recheck again. Okay, because as far as I'm concerned, this particular document I don't have to save, because it's automatically saved whenever someone put any what we call data, new data inside. Okay, so for precaution, please snapshot. If necessary, give it. You can email me or you can PM me the data set that you have chosen along with your team member, so that if I realize your particulars is not in the master list, I'll just add it for you in my Excel document. Okay, as well as in the what we call Google document. Okay. Any question for the master list class? Any question or any comment?
Why I cannot fill my name in the form? I can edit the form.
Same here,
I have-
yesterday.
Me too.
Because you know what,
Dia
I
macam
have,
kita dah isi nama, lepas tu bila refresh balik hilang nama tu.
because I have given the what we call I have checked all the names. That's why I click all the, see, you can edit. You can edit, and then supposedly when once you edit, it will be automatically saved, and it will remain in the master list. Okay, but I'm not sure why. So that's why afterwards, once you have filled up, okay, give a copy to me so that I can update my master list in my Google document as well as in my Excel document. Okay, so that I can monitor which team take which data set. Okay. Any other problem for the master list?
chapter,
Yes,
for the topic, is it better to choose the topic with more data or less data?
it's up to you. You can, you know what? Because more is not superior, less is not good. We don't judge that way because chapter one deals with data. Okay, chapter one helps you on how dealing with data. So what you can do when you have data. So whatever data you have, it could be a very long list data or it's just as simple as short, very short data. So there will be no advantage or disadvantage when you have more data or less data. As long as you know what you want to extract from your data to be your analysis and to be your objective. That's why when you got your, you know, you got your your list of data, maybe it is okay for you to look at few data set and see what you have in mind. Okay, when you have this particular data, okay, what can I do with the data? What types of analysis that I can present from this particular data? So sometimes the more you have, it will give headache to you because maybe because it's too much, you don't know which one to focus. Okay, that could happen. But I think along the way, when you have discussion with me, when you have problems and we discuss together, I think that particular problem can be avoided. Okay, so it depends on you which data set that you wish to choose. If you like a population data set, then choose population. So we also have data on the manufacturing as well. I think with the what we call, if I'm not mistaken, agriculture, so on, businesses, data set, okay, hospital, so on and so forth. Okay, is it okay? Yang tanya tadi ni, is it okay?
Yes, yes, Doctor.
Okay.
Thank you.
Any other question? Any other question?
No, Doctor.
Okay. If no, I'll just proceed with the lecture for tonight. Okay. Okay, class. Usually I use my what we call Microsoft Edge for my presentation during class. But somehow because this subject my last time teaching this subject was in 2018. Okay, so all my slide was in PowerPoint. So I have updated the PowerPoint. So this semester I'm using my PowerPoint. So anything that I wish to draw or explain to you in terms of my own writing, I will move to my Microsoft Word because somehow I couldn't find the way I can edit or write in my PowerPoint presentation. Okay, I think something wrong with my Webform 1. Now, we begin with first chapter, and I hope everyone has already got your textbook because I solely what we call refer to the textbook that I have shared with you the details for that particular textbook. Okay, now let us begin with this part. Now, can someone tell me where you can find this basic hearing statistic, turning data into meaningful insight? Okay, for those who have your textbook, on what page is that? That would be before your second page, right? So at this particular page, you can see the chapter outline. Okay, and you can also refer to the learning objective that is pointed for this particular chapter. So please please go into detail, okay, the learning objective on your own. Okay, I'm not going to discuss that yet. But I want you to look at the what we call this particular in yellow, what we call this cloud. Okay, turning data into meaningful insight. So in chapter 1, what we are talking about will be more or less everything about data. Okay, and the story of how to turn into meaningful insight is the things that we are going to discuss a lot for the, I think, for the rest of 4 weeks. Okay, for this particular chapter. Now, for this particular chapter, we are going to look into 3 subtopics. That will be statistics in engineering. Second, collecting engineering data. And finally, data summary and presentation. And that will include variable, graphical data presentation, and numerical data presentation. So for your project, it will refer to the last 2 here. Okay, it will refer to this particular method and analysis, graphical data presentation and numerical data presentation. It should be easy actually, because this particular topic, I think you have undergone this topic during your secondary school in your form 5, and for those who have gone through your matriculation, you have gone through this particular topic as well. So it should be an advantage for you. Okay, now let's move to the first subtopic, statistics in engineering. Okay, now when we say data, data can come from different types of sources. Okay, data can come with different format. Okay, for example, you have the first one in my what we call I should have my pointer here, but I don't know the formatting is not available for me to pick. Okay, so just look at the mouse. Yeah? So this is the first example of your data in table form. Okay, and you may also have your data in terms of infographic. For example, for this one, eat healthy, be healthy, safe. So this also considered as your data. Okay, and you can also have this particular table, and this represent data as well. Now, the question is how to turn your data into meaningful insight. Okay, so that will require some processes. Okay, now imagine imagine we have this particular analogy. Okay, so you have your, let's say you are the engineer in this case, and you are the one that at the ladder here. Okay, and you have your data, and your data is the things that you need to plug from, and you are using ladder to help you out to reach the fruit. Okay, and in this particular case, okay, how we move, how we process, how we do with this particular data into meaningful insight. So you will require statistics, and that later is what we call your statistics. Okay, so in this particular case, okay, statistics will play a good role, important role for you as an engineer. Now, as an engineer, you will perform experiment. Definitely, somehow, you will involve with a lot of experiment. And of course, when you do your experiment, okay, you will have to collect data. And then that data will be used to explain the relationship and to reveal information about the quality of product or services that you are working with. Okay, so in simple way, you need to have your statistical, what we call knowledge, to help you out on how to turn your data into useful information so that you can explain on your operations or on your products. Okay. And why we need to study statistics? Okay. First, to set clearly defined goal for the investigation. Of course, when you need to perform an experiment, definitely you have your own goal. What that experiment for? Okay, and of course, when you have the objective of your experiment, you know how to perform the experiment. And whenever you plan for the experiment, of course, you are going to plan for the types of data that you are going to collect from your experiment. Okay, so second, make a plan of what data to collect and how to collect the data. So along the way, before you do your experiment, you have to plan what types of data that you need to help you out in what we call in explaining or in gaining what information that you need to reflect your product or services. Third, apply appropriate statistical methods to extract information from the data. Okay, and when you have your data, somehow later you need a tool to turn your data into the meaningful insight. Okay, this is where you need to choose what kind of mathematical statistical tools that you need to use in order to turn your data into the meaningful insight that you need for your experiment. Okay, and finally to interpret the information and draw the conclusion. So from A to D, you can see you begin with your planning, and finally you will have to conclude something from your experiment. Okay, so this is what statistical helps you. Now, what is statistics? Okay, so there will be a difference between statistic without S and statistic with S. So we are now talking about statistic with S. Okay, statistics. Later on, we will see the word without S, statistic. Okay, there will be a difference between statistics and statistic. Okay, now we are talking about statistics. What is statistic? Statistic is the science of data. It is the art of conducting studies or experiment through collecting, organizing, summarizing, analyzing, and finally you make conclusion. So there will be 5 steps or 5 processes in statistics. You begin with collecting your data. Once you get your data, you organize your data. Once you got your organization of data, then you start summarizing your data. After you summarize your data, you do your analysis. And based on your analysis result, you do the conclusion, or sometimes what we call interpretation. And that particular interpretation will reflect your objective of your experiment that you do. Okay, so remember, you need ladder to pick up to reach your fruit, and that fruit is your data. And this particular ladder is what we call statistic. And in statistic, there will be 4 concepts involved actually. Okay, and I want you to read on your own these 4 particular concepts. Okay, from your textbook on page 3. Okay, so statistics require these particular 4 concepts in order for you to comply or to implement the whole process of statistics. Remember, collecting, organizing, summarizing, analyzing, and conclusion. Concluding. Okay, so these 5 steps or 5 processes require these 4 concepts. So that will be from bottom to up. So the first concept that require will be statistical literacy. Okay. Second, followed by statistical knowledge. Once you have got your statistical literacy, you know when people say something about sample, when people say something about population, when someone says about X bar, when someone says about mu, p hat, sample size, whatsoever related to statistic, you know what that particular, what we call notation refers to. Okay, so this is what we call statistical literacy. Okay, you know, whenever people say about statistic, at least basic on statistic, you know what they are talking about. Followed by statistical knowledge. Once you know, okay, mu is the population mean, X bar is the sample mean. Sample size is n, small n. Population size is capital N. So all these refer to your knowledge. Okay, this is your knowledge. Once you have got your knowledge, go higher because you need to analyze. You need to analyze your data. Okay, you need to think of what method should I choose, what variable that I deals with. Okay, so all this require you to think which one is for which. Okay, which method is for which variable, and this is what we call statistical thinking process. Okay, and finally, once you have done your analysis, you have got your result of your analysis, finally you have to have your statistical reasoning. Okay, when you got your result, you have to think. The way you think, I got my result here and I know this is my data. From my data, I got my result, and why is my result this way? And you have to look back to your data. Okay, now I know because my data is this way, then I get this particular kind of result. And you have to input that particular reasoning into your conclusion. So this is where the process begins. From statistical literacy to statistical knowledge to statistical thinking, and finally stop at your statistical reasoning. And bear in mind, class, these four concepts, you will use that until the last chapter, that will be chapter 5. And of course, statistical reasoning, thinking, knowledge will always be there for you to use. And that's why you have to understand the concept and why this particular concept is important in statistics. Okay? So far, do you have any question, class? So far, any question? Am I
So far,
talking?
no, Doctor.
Okay. Clear? Understand?
So far, okay. So far, okay.
Okay, thank you. Oh, now, in order to understand this particular concept, of course, because we have a few assessments that we will need you to do. And that particular assessment would be in terms of project, in terms of tests, in terms of quizzes, okay? So that particular assessment will involve what we call Bloom taxonomy, okay? That Bloom taxonomy actually what we call have some relation with the statistical concept that we have just discussed, the four concepts that we have just discussed. For this taxonomy bloom, okay, there will be different level of taxonomy blooms or cognitive. When I say cognitive, it's referring to this particular remember, understand, apply, analyze, evaluate, creating. So this is C1, this is C2, C3, C4, C5, C6. Okay, so apart from the four concept of statistical statistical literacy, statistical knowledge, statistical thinking, statistical reasoning, which involve in your process dealing with data. Now you have to understand until what level you will be assessed. For your project, it will be until analyzing. Okay, so means that from C1 until C4, all these what we call cognitive level will be tested. Okay, and for your test, for example, sometimes it would be until C5. Okay, it depends. So if you can see, when you need to remember, okay, you have to recall the facts and basic concept. When you have to understand, it means that you have to explain idea or concepts. When you need to apply, means that you have to use information in new situation to answer questions or solve problems. Okay, the same goes to analyze. Okay, when you do the analysis, take apart information to show relationship, causes, and connections. Okay, so these are the things that involved in the taxonomy Bloom and more or less in your assessment that you will do later on. Now, in terms of hand in hand, taxonomy Bloom and your what we call statistical concept, so this is how, okay? So this is how the pair of these two involved, okay? In terms of C1 until C6, from statistical literacy until statistical reasoning, okay? Now, in statistics, okay, there will be terms and concepts that will be on and on repeated again and again, okay, and these concepts are very important for you to know. And if you don't understand that particular concept, what happens is that most probably you will have problem in solving the assessment that you have, or in solving any real life situation that involves statistics. Okay, and this concept involve first variable, second variability, third population, fourth sample, fifth descriptive statistics, sixth inferential statistic, and finally random sample. Just to name a few. Okay, these are the things, or these are the terms and concepts that you will see repeated. Okay, so what are they? Let us look one by one. Now, do you realize this? We call it as skewer. Pencucuk sate. Do you know what is this, class? I'm pointing up here. What is this, class?
Sate.
Satay. Satay. This satay need skewer. Okay, need skewer for the businessman to the seller to burn the satay, right? So this skewer is actually one of the example that involved in engineering. Now, before we understand the terms and concept, the terms and the what we call what's this now? The terms and concept, yes. Okay. I would like to bring you to this particular situation. Later on, we will see clearly what will be the terms referred to. Now, if you have ever buy, okay, skewer from a shop, okay, I put here, this is the wrapper from the skewer that I bought last time. And this skewer, okay, claimed by the company, will have to be 13 cm long. Means that from the bottom here until the edge here, it should be 13 cm. Okay. Now, this is the example of skewers that I bought. Okay. And what happened is that, okay, when you measure, take one by one the skewer and measure the length. Okay. Measure the length of the skewer. For example, let's say I assign 3 groups of you, okay, to what we call measure the length for 3 batch of skewers, okay, and each batch I give 40 skewers to measure, okay, assuming that this particular group already done their measuring, length of the skewers. And we have got 3 different data sets reflecting the length of the skewers. Now, imagine, as I said just now, we have 3 teams measuring the skewers length. I have team A, I have team B, I have team C. Okay? And all of them are measuring 40 skewers each set. When I have got my data, so this is my raw data. Okay, you see my mouse here? This is my raw data. Okay, and from my raw data, I simply put into what we call bar chart. So I have bar chart for data collection by group A, bar chart for data collection by group B, and third bar chart for data collection by group C. All these bar charts reflect the length of skewers that they have measured. Okay, can you tell me what obvious things that you can see from the data or could be from the bar chart? Can someone tell me? Can someone tell me?
Not all sticks are 13 cm.
Yes, correct. See, what's the claim? Originally, the company claims that the skewer would be 13 cm. What happened is that when we take few sample, okay, from for each what we call for each pack, there will be 400 skewers inside. Okay, each pack of skewer will have 400. Okay, I bought 3 packages of skewers and I took sample of from 400 I took 40 only, and this 40 we get this particular bar chart, and we can see obviously the measurements are not the same. Okay, so first you know, okay, this is my data, raw data from my measurement of length, and when I transform that into bar chart, I have this. Now let us see the terms that we need to understand. First, the length. We are talking about the length of the skewers. That particular length is what we call the variable. Okay? What is variable? Variable is any measured characteristic or attribute of interest. What is my interest? My interest is length of skewers. Okay? My interest is length of skewers. Okay? So measured characteristic is the length. Okay? Give another example. Later on, we'll see. We'll look at the other example that are provided in your textbook. Second terms, that will be variability. Okay, remember from the data, if let's say we refer to data measured from group A, this is the data and this is the bar chart. What happened is that we have the first observation, okay, 11.5. Second observation, 12.0. Third observation, 13.2. Until the 40th observation, you get here 13 cm. So what happened is that you have different values of length. Different values of length from observation to observation. This is what we call variability. Okay, so what is variability? Variability is the successive data values that are different each time they are measured or collected. Okay, plus the most important concept in statistics is this one, variability. Because if you don't have variability in your data set, then you don't have to use statistics because you have almost everything the same. There will be no differences, and if there is no differences, there will be no use of statistics. You have perfect data. You have perfect operations. Okay, so no need to do anything. No need to do the correction. Okay, no need to look at what happened to your operation because everything is perfect. But reality, this is what happened. Okay, there will always variability involved in your data. No matter how perfect you set up your experiment, at the end of the day, the result, the data that you will collect, it will be differ from observation to observation. Okay, so remember class, variability is the most important concept in statistics. If there is no variability, no need to use statistics. So far, clear class?
Clear, Doctor.
Okay, clear. Next. Now, the most, I don't say the most trickiest, but sometimes students may mix up the concept of population and sample. Now, imagine this particular skewers is produced by this particular company. Okay, this manufacturer is producing skewers. And this manufacturer will have 3 machines in producing skewers. Machine A, machine B, and machine C. Machine A, this is machine A, this is machine B, and this is machine C. Now, simply look into the manufacturer's profile. The production per day is 500,000 skewers. Means that in one day, the company will produce 500,000 skewers, 500,000 of skewers. How many operations in a week? 5 days. They are operating 5 days in a week, Monday to Friday. How many number of workers? Overall, they have 20 workers. How many machines? 3 machines. So if we guess for the monthly production, assume that the monthly production more or less is 10 millions per month. Okay. From this particular, what we call information, how we would know what is population, what is sample. Okay. Now in this case, if we look, okay, population is the entire collection of object or outcomes. Okay. Or somehow, sometimes we call it as the overall subject or the overall outcome that we are interested in. Now, referring to the production per day, okay, if we can say that the population for 1 day production is 500,000. All 500,000 is the population. Okay. What is the most important word here? The word all here. That's why I put it in capital letter. All 500,000 skewers are referred as population. Or you can say all 10 million skewers is also a population. But that population is for 1 month. Okay? Means that what is your population? Everything or all of your object or subject in that particular definition that you define. If I'm defining 1 day production, the whole 1 day production product is my population. If let's say I would like to say my population is my 5-day production of skewers, what would be the population size of 5 days production class? Class, for 5 days, how many? Class,
2.5 million.
500,000 times 5. 100,000 lah. It will give you 250,000. 2.5 million kan?
Yes, 2.5
2.5
million.
million.
Yes, 2.5 million. So the definition of population is reflecting the time frame that you are referring to. If you say my population is 1 month, so total up for 1 month. Okay, if my population is referring to 5 days, total up for 5 days. Okay, so if let's say I'm talking about diabetes patient in Malaysia, means that I'm talking about diabetes patient from Perlis, Pulau Kedah, Pulau Pinang up until Sabah and Sarawak. Means that if I say all population of diabetes patient in Malaysia, means that the whole diabetes patient that will be in Perlis, Kedah, Perak, Pulau Pinang until Sabah and Sarawak. I can also say the population of diabetes patient in Perlis, means that all the diabetes patient in Perlis is my population. So means that all is the keyword for your population. Now, from that particular population, we need to take out your sample. As I said just now, my skewers, there will be 400 skewers inside. I bought 3 packages of skewers. So from 400, I take out 40 skewers only. Okay, so that 40 skewers is what we call the sample. Okay, so what is sample then? Sample is subset of population containing the observed object or outcome. So some part or subset, okay, from your population is what we call the sample. Okay, if we are referring to the production per day, I said sample for 1 day is 500. So means that you take out only 500 from your 500,000 skewers as your sample to be what we call studied. Okay. Or if you're talking about 1 month, okay, sample for 1 month, you can say 1,000 reflecting some part of subset of your population for 1 month. Okay. Okay, now let us look at this particular object. Okay, you can find this object in your textbook. Okay, that will be on page 3. Okay, that will be internal, what we call internal ring here. Okay, can you tell me what could be possible variable that you can have from this particular internal ring here, class? Class, I know I have that particular answer in your book. What can we have as our variable for this particular internal ring here? Class. Class. First, you can have the diameter. This is the diameter, right? Diameter kan? From this part to this part, okay? So you can have variable A, this part, this small hole here as your variable A, this one as your variable B, and the thickness of this particular ring here is your variable C. So you may have different variables for one particular product. Okay. The same goes to skewers. If you wish to check the thickness of that particular skewer, you can also define the thickness of skewers as your new variable instead of the length of the variable. Now, since we may have what we call sample and population, and we are going to refer to sample and population interchangeably. Okay, means that sometimes I refer to sample, sometimes I refer to population. So there would be some notation that reflect the sample and the population. And what do we have for population? Okay, means that when you measure, for example, the length, remember just now, the length for all 100,000 skewers per day. Okay, so if you are talking about that particular figure for the population, all the measured characteristic is what we call as parameter. Okay, so if you are measuring for the population from the population, all the measures are called parameter. For example, if you are talking about the length of the skewers, okay, so that length is what we call the statistical measure is the parameter. Okay, for example, the sample size and the population size. The population size is notated as capital N. Mean of the population is mu. Variance of the population is sigma squared. Standard deviation is sigma. Standard error of the mean is sigma x bar. Standard error of the proportion is sigma p hat. Now, maybe many of you have gone through this particular what we call concept before, but I need to explain it in again because I believe some of our friends may have not encountered this particular what we call subject before. That's why I need to explain everything, okay, so that everyone will understood and clear with that. Now, there would be measurement from the population. Means that if you measure anything from your population, all the numerical measure must follow this particular notation. And if you are taking the what we call measurement from the sample, for example, this is your sample. This sample is taken from your population. Okay. Any measurement that you measure from your sample is what we call statistic. Okay. Sorry, there is typo error here. Should be no S here. Okay. So statistic is coming from your sample, parameter coming from your population. So what is my sample size? My small n. What is my sample mean? X bar. What is my variance sample variance? S squared. What is my standard deviation of my sample? S. Okay. So I think and what is my proportion for sample? P hat. Okay. So these are the differences between parameter and statistic. Okay. Parameter and statistic. So next time we won't say this. Okay. We are not going to say sample mean, population mean. Maybe we just directly use this particular notation. So when you see this particular notation, I really hope that you can reflect which one is which. Okay, which one reflect the population, which one reflect the sample. Now, there will be few other what we call information regarding your parameter and statistic. Okay, so you can see I will share this particular what we call slide later on, and you can see in detail what are the differences between parameter and statistics. Okay, and I would like to look at the example for parameter. So for example, in 2010, the population of the town numbered about 5,000. Okay, the city has a population of more than 1 million. Okay, so you can see the particular what we call population is mentioned here. Okay, there are 305 doctors in this hospital. Means that the whole number of the overall number of doctor is 305. Means that it's reflecting the population, even though the population is not mentioned in the third example. When it mentioned this way, we knew that this particular statement is reflecting the population. The same goes to the number of students enrolled at the college is 15,000. Okay, so the number of students means that the whole or all the number of students enrolled in the college 15,000 as the population. For example, for the sample, according to a survey of 660 residents, garbage collection was the city service people like most. So in this case, okay, a survey. When you see the word survey, means that that particular information is obtained from your sample, because survey is always reflecting your sample. Okay. The what we call similar to survey, but we do for the population is what we call census. CENSUS. Census is almost the same as survey, but it is for the population. Means that everyone in the population will have to answer the census. Okay, what we have in Malaysia, in 5 year time there will be census made by the Department of Statistics Malaysia. A survey of 2,000 federation members had shown that 48% believe police should have the right to take industrial action. So also here survey. So automatically this is what we call sample, and every notation followed afterward will be following the statistic notation. Okay. Any question so far? Any question so far? Okay.
No,
For
sir.
tonight, I will.
Ada.
Yes. Ada ke tak ada?
No. No question.
No question. Okay. Next is the descriptive statistic and inferential statistic. Now, what will you have later on is what we call descriptive statistic and inferential statistic. Descriptive statistic more or less involved in chapter 1. Mainly in chapter 1, partly in chapter 2. Okay. What is descriptive statistic? Descriptive statistic is used to describe basic features of data by providing summaries about the data, about the sample data in a form of suitable graphical or numerical analysis. The words come from describe, means that is the way how you describe your data. Okay, but since we have the statistical process, which is the collecting, summarizing, organizing, analyzing, and making conclusion. So when we say making conclusion and analyzing, this is where the numerical and graphical involved. Okay, so you can means that you can describe your data using numerical or graphical. And when do we do that? And how to use that? When do we use graphical? When do we use what we call a numerical? Depending on your objective and depending on the suitability of your data and the representation. Okay, so means that in descriptive statistics you have two options. It's either you choose graphical or you can choose numerical. Okay, or you can use both to represent your data depending on your data. And further is what we call inferential statistics. Now, inferential statistics compared to descriptive statistics is much more complex, okay, in terms of the process, because descriptive statistics just involve on how you represent your data. Once you have analyzed, how you can represent your analysis using some graphical or numerical measures. But inferential statistics is where you have to do a lot more processes inside, okay, and more thinking will involve and more reasoning also involved. And this is what made the inferential statistic a bit what we call burdensome for some students. Okay. What is inferential statistic? Inferential statistic is to make inferences about the population using selected sample. And this will be covered in chapter 2, chapter 3, chapter 4, and chapter 5. I forget to put chapter 2 here. Chapter 2, some part of chapter 2 is considered under inferential statistic, especially the hypothesis testing. No, hypothesis testing is chapter 3. Chapter 2 is probability distribution. Okay. Now, what is about inferential statistic and why it matters? Okay. Now, imagine you have your population here. Look at my arrow here. You have your population here, and remember you need to take out your sample. Why you need sample? Can't we take all the population, all the subject, or all the object in my population in my experiment? Yes, you can. But I'm afraid you will spend more time on collecting your data. Knowing that your data, your population will be diverse. For example, if you're talking about diabetes patient in Malaysia, you're talking about 13 states and what we call two federal territory. So there will be more places to go. Or in fact, if you are talking about diabetes patient in Perlis, even the place is so small, but yet you have how many district inside Perlis. So it is impossible for you to go and reach every object or every subject of your population. That's why most of the time you will choose your sample when you do your experiment or when you do your study. Why? Because we cannot have we have limited sources, means that we have limited money, limited time, limited workers to help you out in data collection. That's why we avoid to do the collection from the population. Instead, we choose subset of your object or subject to be your sample, so that you can reduce the time, you can reduce the manpower, okay? You can reduce the hassle and everything. So it would be a bit simplified for you, okay? But what we have to make sure is that in making statistical inference, inferential statistics, we have to make sure that our sample is representative of the population. For example, okay? For example, if you are talking about your population, okay, you have your population here, okay. Let's say you are talking about diabetes patient, okay. You have diabetes patient here. Let's say we are talking about Perlis only, okay. And this is your population. And we need to take out your sample. You choose. There will be some procedure in statistics in choosing your sample, okay. Let's say you have chosen your subject and you have your sample here. And let's say your N here is, let's say, 20,000. Okay. And your sample here only, let's say, 800. Okay. Now what happens is that when we choose our subject to be included in our sample, what happens is that we have to make sure those people that we choose, okay, we choose here, okay, from here is what we call sampling, and this is your sample. When we say inferential statistic, okay, we wish to use the information from the sample to make conclusion on your population. This is what we call statistical inference. Inference. Okay? Means that you use all the information from your sample to make conclusion of your population. That is why it is very critical for you to choose your sample representatively of your population. Okay? We don't want to make conclusion based on sample that is not representative of your population. Okay? So there will be some procedure in statistics that you have to follow in order to make sure that your sample is the representative of your population. And if you follow the procedure correctly, most of the time when you test for the hypothesis testing, okay, you will do the hypothesis testing from your data of your sample, you do the analysis, and finally you do the hypothesis testing, and that hypothesis testing whether you will reject or fail to reject. Fail to reject what? Fail to reject the statement that you are testing. The statement of your population to represent your sample to represent your population. So that is why statistical inference is very important in statistics. Okay. Now, let's move to the first descriptive statistic. I guess descriptive statistic is quite straightforward. So I believe if you read on your own, it would be easy for you to understand. But somehow we just go through in brief what are the process involved in descriptive statistics. As I mentioned earlier, there will be 5 steps involved in descriptive statistics. The first will be collecting data, organizing data, and analyzing data, presenting data, and interpreting the result. Okay, so somehow you know, in this case, for your project 1, okay, collecting data, there will be no step of collecting data because you are given a secondary data. Okay, so means that for project 1, you start with the organizing your data, and then once you have organized your data, you will be analyzing your data, and later on you will have to think what types of method and analysis of representing your what we call data to be so that it will be in terms of meaningful insight. So these are among the steps that involved in your descriptive statistic, and you can see that particular process on what we call on page. Okay, on page 4. Okay, now inferential statistic, as I mentioned earlier, okay, it involves performing estimation, hypothesis testing, determining relationship, and making prediction. So we'll see one by one in the rest of the chapter later on. Okay, hypothesis testing will be in chapter 3, chapter 4, chapter 5. Every chapter involves hypothesis testing. Perform estimation, it will be in chapter 3. Okay. Determine relationship and making prediction, that will be in chapter 5. Okay, as well as chapter 4 for analysis of variance. Now, what is about inferential statistics? As I mentioned earlier, inferential process is to make conclusion for the population using sample. Okay, means that statistical inference is about making conclusion of your population using sample data. Okay, and for this you have to collect your sample, organize, analyze, and finally conclude for the population. So these are the two processes that involve in your what we call making statistical inference. Okay, and as for the notation, if you can see here, okay, if you can see here, the mu, the p hat. Okay, and you have also the x bar and the p small p hat. This is reflecting your population mean. This is your population proportion. This is your sample mean. This is your sample proportion. Later on, we will interchangeably what we call use this in your what we call hypothesis testing and making estimation. Okay, you can see I pointing out here mu, but somehow the pen um, will dia pergi tempat lain ya. So that's why I'm not sure what happened to my device. It is not as accurate anymore because it's not on the things that I would like to write. Now 1.2. We finish with 1.1 on statistic in engineering. Next, we are talking about collecting engineering data. Okay, so imagine now we are talking about data, and we know that data can be obtained from two main sources. The first one is what we call primary source, and second is secondary sources. What is primary source? Primary source, or sometimes we call it as primary data, is the first hand data that you obtain on your own. Means that you don't take your data from any other parties or any other individuals or whatsoever thing. Means that primary data, you yourself collect them. And in terms of getting primary data, you can use survey, or you can use observation, or you can do experiment. Okay, so these are three what we call methods that you can use to get your own data, first-hand data. Okay, as for survey here, survey and observation most of the time involve in social science. In your case, most of the time involve experimental. And in this particular experiment, you will also use what we call observation, because you will have to observe what happened in your experiment. Okay, and the other source of data will be secondary data. Means that you are not the one who collect the data, and it is not a first-hand data. It is data available from different sources, such as it could be from your library, it could be government report, government statements or whatsoever. It could be trade professionals and businesses. It could be private business firm, from the advertising, media, or university research organization. So these are all sources of your secondary data. As for your case, in project 1, your data is obtained from the government source. It is from the Department of Statistics Malaysia, Singapore, and Brunei. Okay. Now, when you collect your data, okay, so this slide reflects if you collect your data on your own. Okay, when you need to collect your data, of course, the reason why you collect your data, you know why you have to do that. Okay, so in the process of collecting your data, the first step that involved would be formulate questions. Okay, and if we are talking about survey, of course you have to know what are the questions that you need to ask to your respondent. Okay, that particular questions will reflect your variable that will be analyzed in your analysis later on. Okay, so in formulating your questions, you have to clarify what is the problem involved. Okay, if you are talking about what we call for example, we take an example of first-hand data. let's say, okay, the simplest one is what usually done by student is when they have to form a survey, they will ask about the what we call characteristic of students. They will ask about the weight, height, okay, weight and height. This is the most common when people do surveys, okay. So when they ask the question, they know what are the things that they want the respondent to share in terms of their data, in terms of their information. So that is why you have to clarify what are the problems that you need to ask from your respondent. Then when you know, once you know what are the problems, then you formulate the question. Okay, and that particular questions will then guide you to your what we call objective of your survey or objective of your study. Once you have designed your what we call survey questions or whatsoever, then you will collect your data. Okay, when you collect your data, you will have to design a plan to collect appropriate data. So it means that you know what kind of data is specific to be collected. Okay, and then you execute the data collection plan. How you want to collect that? Are you going to use the survey? Are you going to use the what we call observation only, or are you going to interview one by one? Okay, so it depends on what types of data collection method that you are going to use. But in your case, for this particular semester, we have given you a secondary data set. So it means that you have got your data in terms of what we call ready-made data. Okay. Next, what you have to do is to analyze your data. Again, when you analyze your data, in this particular case, you have your descriptive statistics. It means that you have to choose either the numerical or graphical methods in your what we call in your analysis. Okay, and finally, you will have to interpret. Okay, so the way you interpret, normally it will reflect your objective of your study. The way we analyze will have to answer what is the thing that you need to achieve in your research objective or objective of your study or of your experiment. So one by one, you will treat the objective and find out what will be the suitable, what we call analysis that can be done. And finally, you will have to interpret your result. Okay. And for this case, bear in mind, always based on your objective so that everything will be guided. Okay. Look at your objective and see what are the method that's suitable to the objective. Now, in collecting your sample, okay, this is the last what we call terms or concept that I mentioned earlier that you need to know. Okay, random sampling is one of the methods that involve in collecting your data. Okay, what is random sampling? It's a way of collecting or selecting a sample where each individual in the population has equal chance to be included in the sample. Means that if you have a population here, okay, say you have a population here, okay, remember you have to make statistical inference, and that statistical inference will be using data from your sample. So what happened is that you have to make sure that those samples selected here are the representative of the overall population. So in order for you to choose this particular people here inside the sample, we will take or we will select them in such a way that each one of them, the probability of choosing them are the same to each other. If let's say my total n here is what we call n is equal to let's say 500. Okay, so here my sample would be sorry, my pen is running away from the station, so just Look at it now. Okay. So n is equal to, let's say, 100 only. So what happened is that the way you choose each person inside here, okay, the way you choose this person is probability to choose this person is 1 over 500. The same goes here. The probability of choosing this guy is 1 over 500. The same goes here. The probability of choosing this person is 1 over 500. So the way we choose is they have the equal chances to be selected in the sample. So that is random sampling. Stop sharing for a while. Okay. 47 of you are in my. I'll just check later on what happened to the rest. Okay. Now, I'm not going to into detail because this is what we call now I have this. I can use my pointer. Okay, the way we choose, as I mentioned earlier, just now is simple random sampling. Okay, random sampling, as I said, the probability of choosing this guy is the same as choosing this guy. Okay, if my n, capital N is 500, the probability of choosing each one of these is 1 over 500. So the way we choose this particular population, in order to get our sample, there will be different ways to do it. It could be done probabilistically, or it could be done using non-probabilistic sampling. For probabilistic sampling, you may have simple random sample, systematic sample, stratified sample, or cluster sampling. Okay, so you can have this, but most of the time, this particular what we call sampling is involved in social science. Okay, for your experiment, less related to this particular what we call sampling method. But for non-probabilistic sampling, you may have convenience sampling, judgment or purposive sampling, quota sampling, or snowball sampling. Okay, so you may have two different types of sampling. Okay, just for you to know. Now, again, related to your collecting data. Okay, when you collect your data, as I mentioned earlier, if you're talking about primary data, means that you have your first-hand data that you collect on your own. You involve in the collection process. Okay, so you may have what we call observation, or you may have experimental. Okay, so if you have observation, what happens is that here researcher needs to observe and measure specific characteristic of variables. No attempt to modify measured variables. Okay. For example, if let's say you are talking about weight, okay, weight of students or height of students. So when you do observation study, you are not going to change what we call the characteristic that you measure. If you are measuring the height, you are not going to change it on your own. You are not just simply change. You measure a student's height, and the student height is actually 170, and you put 155. No, cannot. So you are not going to modify anything. The data is based on your observation. Okay. Now, for experimental study, okay, different from observation, usually in experiment, you will have to make an attempt to impose treatment on subject. Means that you have your subject, you are going to do something with your subject. For example, if you are talking about experiment on a tree, different trees, okay, and we are talking about testing different fertilizer. For example, fertilizer A and fertilizer B. So you wish to make an attempt on how that particular trees, let's say you have four trees, different trees, and you will put different fertilizer for each tree. Okay, so what happened? you impose treatment, means that you put fertilizer, different fertilizer for each for different tree. And what happens is that you are going to observe the effect of fertilizer towards the development of the tree or the growth of the tree. So means that in experiment study, okay, you will have an attempt to the subject. Okay, depending on what you are going to do in your experiment. Okay, so that will be difference between observation and experimental. Now, what is the time now? Can someone tell me what is the time now?
9:48.
9:48.
Okay, just nice for me to stop here. Any questions regarding what we have discussed just now? So bear in mind, class, I want everyone to understand the concept of variable, variability, population, sample, descriptive statistic, inferential statistics. We are going to talk about a lot about variable later on. Every single discussion reflects the variable. Okay, if there is variability in your data, then we proceed with the discussion. Okay, and we are going to refer to population and sample as well. Okay, interchangeably in your discussion. Okay, I stop sharing now. Okay. Okay, before we stop, do you have any questions so far? Or do you have any question regarding your project one? Or regarding your data? Or regarding your team member? Or whatsoever? Class? You have any problem? Or do you have any question or no?
No,
No, no doctor? No, huh? Okay. Now, tomorrow we will have class at 1:30 until 3:30. Okay. Since I don't get any approval for relocate your what we call your slot, maybe due to some of the students may have other classes, so we'll just stick with the timetables as what is inside the timetable in the portal. Okay. So